Numericals are intensity ratio at maxima and minima of an interference pattern. Question number 1. Two coherent sources have intensities in the ratio 25:16. Find the ratio of intensities of maxima to minima. So we know that amplitude ratio R is equal to A1 upon A2, which is also equal to root of I1 upon I2, which will be equal to, here intensities are in the ratio 25:16. So 25:16, that will give 5 upon 4. Now we have to find out I max to I min. And I max is given by R plus 1 whole square divided by R minus 1 whole square. So this will become 5 upon 4 plus 1 whole square divided by 5 upon 4 minus 1 whole square. That will be equal to 9 square divided by 1 square. That is 81 upon 1. So ratio is 81:1. Let's go to second question. Width of two slits in Young's double slit experiment are in the ratio 4:1. Deduce the intensities at maxima and minima in the interference pattern. So let's see. We know that R equal to A1 upon A2, which is equal to root of I1 upon I2. And the intensity is proportional to width, so it can also be written as W1 upon W2 under root. And in our question, width of two slits are in the ratio 4:1. It means this will be 4:1, which will give 2:1. Now we know that I max upon I min is equal to R plus 1 square divided by R minus 1 square, and that will be equal to 2 plus 1 square minus divided by 2 minus 1 square. This is 9 upon 1. So ratio is 9:1. Now consider third question. The ratio of the intensities at minima and maxima in the Young double slit experiment is 9:25. Find the ratio of the width of the two slits. So we are given I min to I max. That is 9 upon 25. And this can also be written as R minus 1 square upon R plus 1 square is equal to 9 upon 25, from where we can get R minus 1 upon R plus 1 equal to 3:5. So we make cross multiplication, 5R minus 5 equal to 3R plus 3, from where we will get 5R minus 3R equal to 5 plus 3, that is 2R equal to 8, or R equal to 4. So R equal to 4 means A1 upon A2 is equal to 4, and which is the ratio of the amplitudes. Now we have to find out the ratio of width of the slits, and width of slits are W1 and W2, and they are equal to I1 upon I2, and I is proportional to amplitude square. So A1 upon A2 whole square, that will give 16 upon 1, or 16:1. This is our answer. Question number 4. Two coherent sources of light with intensities ratio beta produce an interference. Prove that in the interference pattern I max minus I min divided by I max plus I min equal to 2 beta divided by 1 plus beta. So we know that beta equals I1 upon I2, which will be equal to A1 square divided by A2 square. So from here we can say that A1 upon A2 will be equal to root beta. Now I max is k times A1 plus A2 whole square, and I min is k times A1 minus A2 whole square. Now we consider LHS. I max minus I min divided by I max plus I min. Now we put the values k times A1 plus A2 whole square minus k times A1 minus A2 whole square divided by k times A1 plus A2 whole square plus k times A1 minus A2 whole square. So if we open the bracket, so we will get k times 4 A1 A2 divided by k times A1 square plus A2 square. Other terms will cancel out. Here formula is A plus B whole square equal to A square plus 2AB plus B square, and A minus B whole square equal to A square plus B square minus 2AB. So K will cancel out. So we have got 4 times A1 A2 divided by twice of, here there will be 2, that is missing. So twice of A1 square plus A2 square. So this will become 2 times A1 A2 divided by A1 square plus A2 square. Now we divide each term by A2 square, means numerator and denominator both. So twice of, when we divide by A2 square, so we will be left with A1 upon A2, and here this will become A1 square divided by A2 square, and this will become 1. Now A1 upon A2 equal to root beta, so twice of root beta divided by A1 square upon A2 square will become beta, so beta plus 1, which is RHS. So here question should have been twice of root beta divided by 1 plus beta. Now let's see another question. If one of two identical slits producing interference in Young's double slit experiment is covered with glass so that the light intensity passing through it is reduced to 50%, find the ratio of the maximum and minimum intensity of the fringe in the interference pattern. So here, suppose I2 becomes 50% of I1. So 50% of I1. So that will be equal to I1 upon 2. So we can say that I1 upon I2 equal to 2. Now we know that R equal to A1 upon A2, which is equal to root I1 upon I2. And here we have I1 upon I2 as 2. So this will become root 2. So we have got the value of R. And we know that I max divided by I min is equal to R plus 1 square divided by R minus 1 square, and we put the value of R as root 2, so root 2 plus 1 square divided by root 2 minus 1 square. So if we rationalize it inside, so what do we get? Root 2 plus 1 times root 2 plus 1 divide by in denominator root 2 minus 1 times root 2 plus 1 and whole square. So here in the numerator we will get, this will become 2 plus 1 plus 2 root 2 whole square, and in denominator we will get, this is 2 minus 1, that is 1. So our ratio will become 3 plus 2 root 2 whole square divided by 1, and 1 is not needed. Now we expand it, so this will become 9 plus this will become 8 plus twice of the 2, 3 to just 6 to 12 root 2, which will be equal to 17 plus 12 root 2. If we put the value of root 2 as 1.414, then we will get around 33.968, which will be equal to 34, which is our answer. Thank you for watching.